All right. Hello once again, and this is your video lecture on static electricity. So, as we begin our unit on electricity, some of the questions that we want to answer are: what is electricity made of and where does it come from? So, we're going to start our unit with static electricity, and some examples of static electricity that you might be familiar with would be walking across the carpet, particularly if you're kind of shuffling your feet as you go across the carpet, maybe in your bare socks or in your house slippers, and you reach for a doorknob and zap, all of a sudden you get a shock. Another example you might be familiar with is coming inside from the cold, pulling off your hat, and boing, all of a sudden all of your hair is standing on end. So what's going on here? Why does that happen? What is moving around? And why does it seem to happen more in the wintertime? So in order to answer some of these questions about electricity, we have to go back. We have to go back to the beginning of the year when we learned about the structure of the atom. So if you remember, in the beginning of the year, we talked about how in the center of every single atom is a nucleus. And inside of the nucleus, you have two kinds of tiny particles called protons and neutrons. And your protons have positive charges, your neutrons are neutral. And orbiting around the nucleus are teeny, 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 tiny particles called electrons. And these electrons are so small that we don't even include them in the mass of the atom overall. So if you look at the atomic mass of any element, it doesn't include the electrons because they're so small. So if you look at your chart, you have your protons with a positive charge, you have your neutrons with a neutral charge, and you have your electrons with a negative charge. And your protons and neutrons are roughly the same size. They have about the same mass. But electrons have almost no mass at all. Comparing the mass would be almost like trying to compare the mass of the Death Star to the mass of one single tiny little porg. So when we have a neutral object, what that means is that the number of protons and the number of neutrons in the atom the number of protons and the number of electrons in the atom are the same. So when you have the same number of positive protons and the same number of negative electrons, you end up with no charge. Now you can have as many neutrons as you want in here because the neutrons are neutral and they don't change the charge of the atom. As long as your electrons and your protons are equal, you will have no charge. You will have a neutral object. But not all objects are neutral. Objects can be charged. Objects can be positively charged or they can be negatively charged. Static electricity occurs when there is an imbalance of positive and negative charges. Atoms that lose electrons end up having more positive protons than they have negative electrons. So that imbalance gives them a positive charge. If an atom gains electrons, then it ends up having more negatives than positives, and it ends up having an overall negative charge. So, how does an atom end up losing electrons or gaining electrons? Well, atoms can steal electrons or they can give electrons away. And one of the easiest ways to steal or give away electrons is through friction. Now, if you remember, we talked about friction a little while ago, and it's when two objects rub together. Well, as these two objects rub together, electrons may be transferred or moved from one of the objects to the other. The more the two objects rub together, the more chance the electrons have to move around. So when we are talking about charged objects, there are a few rules. So the laws of electrical charges are, first of all, opposites attract. If two things have opposite or different charges, for example, a positive and a negative, they're going to attract each other. They're going to pull towards each other. The second law tells us that objects with the same charge, for example, two positives or two negatives, are going to repel each other or push away from each other. Now, the third law tells us that positive objects are attracted to neutral objects, and negative objects are attracted to neutral objects. So why are both positives and negatives attracted to neutrals? So let's talk about an example that either I've done in class or that I'm going to do in class, which is a wall and a balloon being attracted to each other. So when you rub a balloon against your hair or against a sweater, it picks up extra electrons. Your hair or your sweater give away electrons and the balloon steals them. So as the balloon picks up these extra electrons, it gains a negative charge. Walls, for the most part, have no charge. Walls are neutral. But if we bring the negatively charged balloon up close to this neutral wall, the negative charges in the wall get pushed away. Why? Because like charges repel. Remember, just because the wall is neutral doesn't mean it has no charges. It just means it has an equal number of positive and negative charges. So as we bring the negative balloon close to the wall, those negative charges get pushed back. And when the negative charges in the wall get pushed back, the only thing left right there next to the balloon are the positive charges. So the positive charges in the wall are now attracted to the negative balloon, and so the balloon will stick to the neutral wall. So another example is getting hat hair in the winter. So if you think about wearing a wool hat in the wintertime to keep you warm, when you come inside and you pull that hat off of your head, it rubs against your hair. Well, your hair tends to give up electrons. So your hair gains a positive charge, and those electrons move into the hat. So, but your hair isn't just one single piece. Your hair is made up of hundreds of strands. Every single strand of hair now gains a positive charge. So each of those strands of hair now has the same positive charge. So all of your hairs are trying to get as far away from each other as they possibly can, and that's what gives you that crazy hair sticking up all over the place when you pull your hat off in the winter. So which substances will take electrons and which substances will gain electrons? Well, I'm not going to spend a ton of time on this, but there is a thing called the electrostatic series, and it's arranged in terms of how well and how strongly different things hold on to their electrons. So the thing that you need to remember about the electrostatic series is these things up here have a very weak hold on electrons, so they tend to give electrons away. And this includes things like your hair and glass. These things are going to give up electrons and become positively charged. As we come down here to the bottom, we have things like rubber and polyester and foam and plastic grocery bags. And these things hold on to electrons very strongly. And we call those insulators. So they allow electrons to kind of build up inside of them. So these insulators are going to be the things that gain electrons and gain a negative charge. So if we look at this electrostatic series, if you were to rub hair and wool together, which one would lose electrons and which one would gain electrons? So human hair is up here, pretty weak hold on electrons. Is the hair going to lose electrons or is it going to gain them? And we have wool is lower, it's got a stronger hold. Is the wool going to lose electrons or gain electrons? And what about if we were to rub lucite and silk together? Which one of these would lose electrons? Which one would gain electrons? Just write your answer in your notes. And what about rubber and cotton? Rubber is down here with a pretty strong hold on electrons, and cotton is up here with a weaker hold. So which one would lose electrons? Which one would gain electrons? Put that in your notes. And finally, what about if we were to rub glass and foam together? See that glass has a really, really weak hold on its electrons. Would that gain the electrons or would it lose them? Versus foam, which holds on very strongly to its electrons. Which one would lose electrons? Which one would gain? So if you get enough positive charges on one object and enough negative charges on another object, they don't even have to touch each other in order for these electrons to move around. Sometimes just getting close to each other can make the electrons jump across a gap. And when electrons jump across a gap of air, this causes a spark. So a small spark might happen if you have shuffled your feet across your carpet for several minutes and you get your finger close to but not quite touching the doorknob. You might see and feel a little spark. But if we look on kind of a grander scale, a big scale, one of the most impressive sparks that we see in nature is a spark between clouds and the earth. And that is what is happening when we have lightning. And we'll talk about that a little bit more in class. So what we've already learned is our rules of electrical charges. Opposites attract, likes repel, and both positives and negatives are attracted to neutral objects. So for a little bit of extra credit, let's try a little puzzle. Now this puzzle involves something called a pith ball. And a pith ball is basically neutral, but it can become charged. So we're going to talk about charged or neutral pith balls. So here's your puzzle for a few points extra credit. Using the laws of electrical charges, opposites attract, likes repel, both positives and negatives attract neutral objects. Let's talk about 4 pith balls suspended on threads. We know that pith ball number 3 is negatively charged. We know that pith ball number 4 attracts all of the other pith balls. We know that pith balls number 1 and 2 repel each other. And we know that pith ball number 3 attracts all of the other pith balls. So draw what you know. Draw your 4 circles, your 4 pith balls. And the only charge that we are given is that we know that pith ball number 3 is negatively charged. So using your laws of electricity and electrical charges, try to figure out what charge balls number 1, 2, and 4 might have. Like I said, if you figure it out on your own, I'll give you a few points extra credit on this homework grade, and we are going to talk about it in class on Friday. All right, so when you have a neutral object, there are three ways that that neutral object can become charged. And those three ways are friction, contact, and induction. So if we remember, friction is when two objects rub together and one of them gains electrons, one of them loses it. So one becomes positive and one becomes negative. Before you rub the objects together, both of them are neutral, but after rubbing, one loses electrons and becomes positive, the other gains electrons and becomes negative. So which one becomes positive and which one becomes negative? Well, in order to figure that out, we look at our electrostatic series. The ones that are higher up here have a very weak hold on their electrons. The objects down here have a much stronger hold on their electrons. So the objects up here are going to lose electrons, and these tend to be considered conductors because they allow electrons to flow pretty easily. The objects down here hold on to their electrons really strongly. They're insulators, and those are the ones that gain electrons. So the second way that objects can gain a charge is through contact. When you have contact charging, you can get static shocks. So contact transfer occurs when a charged object is brought into contact with another object that has a different charge. It might be the opposite charge, or it might just be a neutral object. Some or all of the electrons will transfer between the two objects, and the goal here is the two objects are trying to balance the charge. They're trying to balance out the number of electrons they have. And in the case of static electricity, let's say you have shuffled your feet across the carpet, your body picks up extra electrons and you gain a negative charge. So when you move your hand towards a neutral object, like a doorknob, the excess electrons you have want to transfer into that other object. The movement can sometimes be seen as a spark, and sometimes those electrons want to transfer so quickly that you can actually get some pain just due to how fast the electrons are jumping from you to the doorknob or whatever the other object is. So I'm not going to ask you to worry about the charging by contact with a negative rod or charging by contact with a positive rod. Just skip that part in your notes. And we're going to talk about induction, which is our third means of charging an object. So induction is when an electrical charge is transferred from one object to another with no direct contact. Remember, with friction, two objects have to rub together, so they have to be in contact. Contact transfer, it says it in the name. They have to be touching. They have to be in contact. With induction, there's no direct contact necessary. The induced charge is opposite to that of the charged object producing the charge. And I'm not going to go hugely in depth into this. If you are in the honors class, I will be talking about it a little bit more in class. If you're not in the honors class, I would not worry too much about this.